Hello everyone, welcome to our ChemTube series. Thank you for giving us your support. Today we will be learning about how to apply Markovnikov's rule. So for those J2s who have just started with organic chem, probably these new techniques on applying rules and coming up with which one is more stable, which compound is an electrophile, which is a nucleophile, all this information is slightly tedious. So be rest assured that these are definitely going to get better as the time goes. So for now, today we are going to look at how to apply the Markovnikov's rule. Okay, so the first things first, once you see an alkene and the information about what is the reagent and the conditions that's going to be used for a particular reaction, you will have got to ask yourself the very first question. If this alkene is a symmetrical alkene or an asymmetrical alkene. So here you can see two alkenes here that I've drawn out. So the first one on the left hand side, an Itin, is clearly a symmetrical alkene whereby it has the line of symmetry here. Whereas over at the other side, which is a propene, you do not have a line of symmetry because there's clearly an additional alkyl group that's attached to the double bond. So what we can see is there's two types of carbocations that can be formed in the presence of an electrophile. So let's say in this question, we are going to look at the addition of hydrogen in the presence of nickel catalyst. Okay. So for the first one, which is the Itin on the left hand side, there can only be one type of carbocation that is drawn here. And there isn't any other varieties here basically because it's a symmetrical alkene. Whereas on the other side, for the propene here, we have two types of carbocation, whereby the electrophile, which is the H+, so the electrophile here is the H+, has either attacked the carbon with the two H's, so the electrophile has attacked the carbon with the two H's, therefore it yields the first carbocation, or the second carbocation, whereby the electrophile, the H+, has attacked the carbon with the methyl group. So that has yielded the second carbocation. Okay, so over here the context is which carbocation is favored more and which one would lead to a more major compound. So the next one that we have drawn out here is showing the sequence of which type of carbocation is more favored. So you can clearly see that the carbocation with more alkyl groups is the most stable carbocation. And the one with the least number of alkyl groups, in this case, it's the methyl carbocation, is actually considered to be the least stable. And why do we say that? Okay, see, actually the R groups, in other words known as the alkyl groups, are electron donating in nature. Okay, so they are basically electron donating in nature, and they would donate the electrons towards the carbocation that's actually lacking electrons, or you could also say that they are deficient in electrons. So when they donate electrons to this carbocation, it makes them more stable and more probable to produce the expected yield of products, which is the major product. Okay, so that is why we have got to look at the more stable carbocation. So in this case, back to the case of the propene here. So for the case of propene, we have the two carbocations. So if you take a look at which one has the more number of R groups, you can clearly see that for this carbon here, on the left hand side, the carbocation, you have a R group here and you have another R group here. Whereas on the other side, for this carbocation here, you have only one R group, which actually categorizes it to be less stable. So since this is less stable, this will not give you the major yield, whereas this carbocation will then move on to the major yield. So I hope you understand this this entire rule about Markovnikov's rule. Thank you so much for viewing my channel and hope to see you again soon.